All right, so there are going to be two Theory 4 videos for Distance 3. Distance 3A, I'm going to show you how to do a 12-tone matrix. Distance 3B, I'll show you how to get started on the homework. So a couple of terms. We're going to be talking about the prime, the inversion, the retrograde, and retrograde inversion. The 12-tone we're using comes from page 180 in your anthology, the Schoenberg Fourth String Quartet. And you will also need a matrix. There are several of these in your anthology that you can use. I also sent you another PDF if you need to print another one out. And it's on page 185, the one that I'm using. So here we have the opening of Schoenberg's Fourth String Quartet. This is a work that uses 12-tone. Now, you might remember that there are some good reasons that Schoenberg decided to develop this system. One of them being that it was difficult to write atonal music because there were so many ways that tonality could creep back in. And by having a system where all 12 tones are used before you repeat a note, gave it a lot of elegance. Now here's the thing though, is we're not going to just use just those 12 notes, because we could take all those 12 notes and move them up a half step, and then suddenly we get a whole new set of 12, right? Or we can move it up another half step, and then we get a whole new set of 12. So we can transpose our 12-tone row. The other thing we can do is we can take the 12-tone row and flip it upside down, so any note going up would go down, any note going down would go up, right? We get the mirror image. So we have the inversion. We could also take the inversion and we could do it like transposed up or transposed down. We could do the 12-tone row backwards, retrograde, and do it from last to the beginning instead of beginning to last. And we could take the retrograde and transpose it up or down. And then lastly, we could take the inversion and the retrograde, and then we could also transpose that. So we actually get a lot of different ways that we can do combinations of 12 notes. So if you take a look at this opening, we've discovered that here we have this funky looking H. Which in German is Hauptstimme, and that means primary voice. Why does he need this H? The reason is in atonal music, it might be difficult to tell who is foreground and who is background. It's very clear in traditional music where somebody's just going oompa, and someone else has a lyrical melody. You know who's foreground and you know who's background. But it may not be that way in a piece that doesn't have a tonal center. You might not know who's supposed to take the lead. In this case, Schoenberg, to solve that problem, uses this H and designates this as Hauptstimme, the primary voice. That's the primary voice. You'll see later on, he has one with an N. And he's saying that that's the secondary part. So as the primary voice is sort of ending, we're supposed to hear this as a counter melody. So even though the work is atonal, it's still using traditional concepts of like melody, counter melody, foreground, background, that kind of stuff. All right, so the first 12 pitches in our Hauptstimme, in our primary voice, are 12 different notes. Now you'll notice there are repeats, and these were some allowances that Schoenberg made when he was doing 12-tone. Direct repeats are okay. Also trills. So you could trill between two different notes, And the way that Schoenberg saw it is that if you were to take two notes and trill them, that's kind of the same as just holding the note long, like a chord. So direct repeats and trills are totally legit. Also tremolos. So these were times when he made an exception in repeating a note. The direct repeat felt just like a longer tone. A trill or a tremolo is more like just a chord because they're being played together. All right, so here we have our 12 notes, and I'm going to take these and I'm going to write them at the very top of my matrix. P0, that's one of our terms, prime 0. Prime means that it's not upside down, it's not backwards, it's the original, the prime. 0 means we have moved it 0 half steps up. So P0 is the original version, untransposed. And if we go ahead and start and put all those notes, we should be able to fill out the top row of this grid. All right, so we've got our first 12 notes. Now that we have P0, we actually already have completed another row. Take a look. If we start here and go backwards, that gives us retrograde 0. It's the backwards version, but now it's untransposed. So we can just go ahead and call that R0. P0 goes this way. The retrograde, R0, starts with B and goes that way. So there you have it. Now, the next step after you do this is you have to figure out the inversion. We're going to take this 12 tone and we're going to flip it upside down and come up with the inversion. All right. I'm going to go ahead and put my notes here. So if you take a look, here we have P0 written out. Here we have P0 notated, which frankly I think it makes it easier to do the inversion. So now the plan is for I0, we're going to take whatever we do on this and then do the mirror image of it, the flipped upside down. So here we have D, and it goes down a half step. So this D will go up a half step. Here we have C sharp, and it goes down a major third. So this E flat goes up a major third. So whatever the P0 does, we just mirror it and do the exact opposite going the other direction. And I'll tell you what, why don't you try working out the rest of this and go ahead and hit pause and finish it. And then when you think you've got it done, you can unpause and you can see if we did it the same way. All right, that took me way too long. I usually do it better than that. Sorry. But anyway, we should have 12 different pitches, and the way to double check is start on the bottom and then just make sure you've got every half step up. B, C, C sharp, D, E flat, E, F, F sharp, G, G sharp, A, B flat. So there we got it. We have one of each. Now, a good question is, does it matter if I do F sharp or G flat? The answer is it does not matter. In fact, that's why most theorists don't even use the regular traditional way of labeling it. They use integer notation. So instead of C sharp or D flat, they'll just use 1, right? C is 0, C sharp is 1, D flat is also 1. So that way you don't get confused between C sharp and D flat. We will not be using integer notation, but that's because we live in Georgia and we do things behind the times. No, that was supposed to be funny. Sorry, I guess it wasn't funny. No one's laughing. Okay. Let's go ahead and put I0 into our matrix. And it will go here. Sorry about that. Okay, so now we have I0, and which also means we have the retrograde of I0. Right there. So if we take I0, but then do it backwards, starting from the last node to the first one, then we have Ri0. So that's the retrograde inversion, one of our other terms. So now we have P0, I0, R0, and Ri0. Now we need to start taking our original 12 tone and start transposing it up half steps. The original one started on D. If we transpose it up a half step, the next one should start on E flat. So we can put P1, since we are taking it and moving it up a half step, we can put P1 right here. So D up a half step, E flat, C sharp up a half step to D, A up a half step to B flat. You get the idea. If you want to try working this out first and pause it, go ahead, and then when you're done, I'll have the answers for you. There we go. And of course, now that we have P1, we can also go ahead and put in R1. So we have P1, and if we do P1 backwards, we get the retrograde one. Now, again, it doesn't matter if you put G flat, that's fine. If you put D flat instead of C sharp, that's fine. I always just go to, if I can go to 3 sharps or 3 flats, key signatures, I usually do that. Now, the next one we need to do is P2. So where would we start P2? Well, if P1 starts on E flat, P2 will start on E, because now we're transposing it up one more half step. And so what I'm doing is I'm just taking P1 and then moving it one more half step up to come up with P2. If you want to try this first on your own, and then so you can pause the video and then unpause it and see how you did. All right. Now, where is P3 going to go? If this one started on E, P3 would go here. And P4 would go here, P5. I hope you're getting the gist of it. When you're all done, you will have the entire matrix filled, and I would strongly encourage that you try filling one of these out yourself. And just so you know, you don't have to go in order P1, P2, P3 like that. For example, if I wanted to, I could just jump right to P5, because I know the difference between P1 and P5 is 4 half steps or a major third. So I can just take all of P1 and move it up a major third. Now, I bet some of you are starting to think, integer notation would make this a lot easier, because instead of having to think about major thirds, all I do is add the number 4. Well, tough tamales, I'm teaching this lesson using standard notation and not integer notation. Go ahead and finish this 12 tone, and you can pause it and go ahead and finish it, and I'm going to go ahead and put up the rest. All right, I've got it filled in. And here's the thing, a good way to double check is again to go up and by half steps see if you have one of each note. Let's try P3. F, F sharp, G, G sharp, A, B flat, B, C, C sharp, D, E flat, E, back up to F. So it looks like we've got one of each. Now what we can do is we can go ahead and put all the other R's and all the other RI's in. So to do that, you just figure out, just use the same number, etc. Now to figure out the I's is we have to start with D, and then to find I1 we have to go up a half step. So I1 should start on E flat. So hopefully you get the idea. So anyway, that's how you do a 12-tone matrix. Now, before we end, how many different 12 tones can there be in using just one starter 12-tone aggregate? Well, we have 12 primes, we have 12 retrogrades, we have 12 inversions, and 12 retrograde inversions. So that actually gives the composer 48 possibilities on how they can use their 12-tone realm. So it's a very elegant system to do this kind of music.